You've mastered LeetCode. Your coding interviews are solid. But then you hit the ML system design round, and suddenly you're drowning in ambiguity. No clear requirements, no single right answer. Just open-ended questions about latency, scalability, and trade-offs. Here's what most engineers miss. ML system design isn't about proving you can implement the perfect model. It's about demonstrating you can think through a messy, real-world problem and make reasonable decisions when information is incomplete. The core shift is moving from, how do I optimize this model, to how do I build a system that actually solves the problem? That means asking questions before diving into solutions. What's the latency budget? What's the acceptable error rate? How much training data do we actually have? What's the deployment environment? These constraints shape every technical decision you'll make. The interviewer isn't testing whether you know the latest architecture. They're testing whether you can identify what matters for this specific problem. Start by clarifying the problem statement. Rephrase it in your own words. State the success metrics clearly. Are we optimizing for precision, recall, user engagement, cost? Then estimate the baseline. A simple heuristic or existing solution gives you a target to beat. This step alone signals you're thinking practically, not academically. Next, break down the system into components. Data pipeline, model training, serving infrastructure, monitoring. For each component, identify the bottlenecks. Is data collection the constraint? Is inference latency critical? Will models drift quickly in production? Map the data flow from raw input to final prediction. Where are the failure points? What needs to be robust versus what can be approximate? Now tackle the ML specifics, but keep it grounded. Start simple. A logistic regression or random forest establishes a baseline and reveals whether the problem is even learnable with your data. Only then justify more complex models. For each modeling decision, explain the trade-off. Neural nets might improve accuracy but increase latency and complexity. Ensemble methods boost performance but hurt deployment speed. Show you understand these tensions, not just the algorithms. Think through the data lifecycle honestly. Where does training data come from? How do you ensure it's representative? What's your label quality? How will you handle concept drift? The best model fails fast if production data looks different from training data. Discuss monitoring, retraining pipelines, and fallback systems. This separates textbook knowledge from production readiness. Deployment is where rubber meets road. Batch or real-time serving, cloud or edge. What's the rollback plan if the model degrades? Address latency constraints directly. If predictions need to be under 50 milliseconds, your model architecture and serving infrastructure must align. Mention canary deployments, shadow testing, and automated rollback triggers. This shows you understand ML systems live and die in production. Finally, ask smart questions about the team structure, about the existing infrastructure, about the failure modes, about the monitoring and observability needs. These questions reveal you're thinking like a builder, not just a solver. They demonstrate you care about maintainability, collaboration, and long-term success. The hard part? Fighting the urge to impress with complexity. Interviewers reward clarity over cleverness. They want to see you prioritize effectively, not enumerate every possible technique. They're testing whether you can navigate uncertainty, make reasonable assumptions, and communicate your reasoning transparently. Here's your move for this week. Pick a familiar ML problem recommender systems, fraud detection, image classification. Write out the full system design in one page. Data sources, model choices, serving approach, monitoring plan, failure modes. Then explain it to someone non-technical. If you can't make the trade-offs clear, you don't understand them yet. Practice this until the narrative flows naturally. System design interviews feel intimidating because they're unstructured. That's also why they're valuable. They reveal how you think when the path isn't marked. Prepare by practicing structured thinking, not by memorizing architectures. Next time you face that blank whiteboard, remember, the goal isn't perfection. It's demonstrating a methodical, pragmatic approach to building real ML systems. That's what gets you the offer. Comment below, what's the hardest part of system design for you? Is it asking the right questions? Handling the ambiguity? Or explaining your trade-offs? Let's talk about it. Subscribe for more on navigating the ML engineering career path. See you next time.